So today I worked on fine-tuning a Distilbert model for emotion recognition. So first, I will just let you know the process what I have followed. In the end, after like trying again and again, so at the end I have already exhausted my GPU, so it have taken me so much time. So what I have done, I have installed everything we need to fine-tune things like we have transformers, accelerate datasets, Birdwise, and UMap learn. So after that, what I have done, I have imported pandas as PD, then Hugging Face from Hugging Face Hub. Then I imported list of datasets, like all the datasets which are available to us in the form of list. And then we have all datasets list. Uh, we can skip till here. Like what I am doing here from datasets, I am loading a dataset so that we can test on it. So I must have opened this dataset with us, emotion dataset. Let me check. So this is the dataset which I have used, which is provided to us by Hugging Face. And in this data we have sentences and like I didn't feel humiliated. This is sadness. And similarly, we have multiple labels here. Like we have sadness, anger, love, surprise, fear, joy. So I think we have six or seven labels here in our data. And we have three type of embedding. We can see here we have training, validation, and test. So let's move back to our fine tuning. So what I have done here, I have loaded this data set and then in emotion, I have loaded this data set in then emotion dot set form. Like I have set it the type of uh, like data which we will get in the form of pandas, the format of the data. Then what I have done, I have like used the head, emotional head of train here to get like just five of the first five of uh, sentences, or we can say the data from dataset we have accepted first five rows from there. Then what I have done, I have to see how many labels we have in our data. So I have written this classes is equal to emotion, then train dot features label dot names. So I have accepted all the labels in our data. We have one, two, three, six here, which is sadness, joy, love, anger, and fear and surprise. In this data set, which we are using here, AI and emotion. Then after that, I have also printed, like here we can see that we have only label. And if we compare it with this, so we have this classes here, and then we have this label also. Like uh, we can also say this as class, like sadness, anger, love. So we are not getting this here in first. So that's why I have extracted the label names, and then we have added that label name using a lambda expression to our the data before, and we can see now we are getting label name also, uh, include also including label here for the first five things. Then we going to analyze our data set, like what we are using as a data set, how many what things we have in this data set which we are using DRI slash emotion. So here what I have done, I have just extracted the label name and all the value label counts. And then what we are doing, we are just plotting it on a visible graph and then just labeling it in the frequency of classes and label name everything. So these are label name frequencies. So we can see that we have more number of sentences with joy categories. Then we have sadness, anger, and here I have set it to horizontal. But if we want, we can also convert it to another way around. If I try to run this, so we can also get this in this manner. And I have all sorted it in ascending order, so that's why we are getting joy in the end. When we turn to like vertical, then what I have done, we can ignore this for now. Then we have text to token conversion. Here, what I am using auto tokenizer, and we are using the auto tokenizer of distilled BERT model here, which we are using here. And then I am using my own text here, like I love machine learning, and tokenization is awesome to see how this sentence is going to be converted into tokens. So encoded text, I am using tokenizer of distilled BERT here, and then we are printed the encoding test. So this is the encoding test. Like we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many like input IDs we are getting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have nine words in our sentence, or we can say nine characters, uh, and we are getting 12. So exactly, I'm going to explain why we are getting. So this first and second is the like tokens inserted here by our model to make a separation. So this is the CLS, like a token, special token, which we insert in the starting of our sentence. And in the second, 102 is the special token which creates separation between two sentences. And this is our text. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So for this nine in this sentence we have nine words, and here we are getting 10, and we are getting attention mask, like on which things we need to like give our attention more. This is the like basic explanation of attention mask, most basic. So we need to keep our attention on every word here. And let's see how this sentence is converted into the tokens. So we can see here that I love machine learning, and then this exclamation mark and full stop is one token. And here we can see that we broke down this word tokenization into two. So that's how we got like 10 input IDs in a sentence where we have nine words or characters. So let's see how big is our vocab size while using this distilled BERT base model. So we have vocabulary size of 352, and the maximum model length, like the maximum length of the input which this model is capable of processing at a single time. Okay, so then what I have done here, like I am now trying the tokenization in our emotion data, the data which we are fetching from this uh, data set. So I am resetting the format. If you remember, we have set this format to, uh, I think, pandas. Yes, I think we have set it to pandas. Yes, we can see here, but I am now resetting it so that we can use it according to our distilled BERT model. So here what I am doing, I am just extracting input IDs. You can see uh, this output. I'm not able to explain. Like, yes, we can see. So when we have multiple sentences, how tokenization works be behind the scenes. So we will consider the length of the longest, because we have this data where the length of the sentence is different for each sentence. So what we're gonna do, how the tokenization gonna work here. So we will take the length of the longest sentence, and then we will like tokenize it in this way. So we're going to see which is the longest sentence. So uh, let me go to attention mask of this. No, no, no. Okay. So we this sentence is not the longest one because we got a zero here in the attention mask matrix. So let's forget. So how this will work? So this sentence may be something. Let us see what is the first sentence we are getting. I did feel humiliated. So this is the starting token, special token. One, two, three, four, five, six. So this must be some other sentence, or maybe it has broken down the tokenization phase, broken down into the tokens. So we get more tokens than the sentence. This also can be the case, but you can see this 0000 means this much longer is the length of the longest sentence here. So we are using the longest length here. So that's the reason we are getting this much zeros because the sentence length of this sentence is a little short. Then what we are doing, we are generating and encoding over our emotion data, the data in our like this emotion data set. And what we are doing, we are mapping over it and then tokenizing it to like get different things here, like different type of data which we have in our data set. So we can see we have training data, validation data, and test data, and we can also verify it. We have training, validation, and test data. Okay, so that's what we are going like trying to locate here. So then we can uh, build a model. Like if I print text, we have this in text, which we set already above. Then what I am doing, if I tokenize here using PT using PT, so we will get nothing different, but we will get a tensor here. Nothing else, an attention mask. You can see is everything similar to that sentence. I love machine learning. Tokenization is awesome. Then to generate a model, we will going to import an auto model, use auto model here, and from pre-trained, I am going to use model checkpoints here, and then I'm going to list the hidden shapes. What is this? Like, oh God, what? Okay, let's now jump on to the fine tuning the transformers. So here, what I am doing, I am from transporter, I am transformers. I am importing auto model for sequence classification. So this is the special token for or special like method provided to us by Hugging Face to fine tune the models or to push training data, something like that. So here what I am doing, firstly I am looking what is the device. If CUDA.torch is available, then use like GPU is available, use GPU. If it is not GPU is not available, then you only use CPU. So we are doing it here, and then we are using pre-trained model checkpoint, and num labels become num label, and we are at the end we are saving it to device. So we can see what is the device here. Device is CPU here because GPU is not available, and because I am not I use GPU before training this model because I spend a lot of time like understanding to the depth how fine tuning works. Then from transformers, I am importing the training arguments. Then again, we are using the batch size 64. And then model name is the model which we are already using distilled bird fine tuning emotion. Then we have some training arguments like we will going to use two training epochs and then learning rate will be this. Batch size we have already have. Okay, then what I have done here, I am like returning what is the accuracy. After we train this model, we will get all this data with us, which is the training accuracy and F1 score of our training. So we are looking for it. So that's why I use this. Then at the end, I am using trainer.train, and it almost taken me. 3.5 hours. You can see here, and after completing its execution for 3 and almost 3.5 hours, it returned me something, some error. So I am looking forward to resolve it. And actually, at first when I tried it using GPU, it worked, but somehow I got a refresh in my environment and not able to save that model. So that's the reason I need to run it on CPU again. But this time I got an issue. So I will try to like resolve this as soon as possible. And tomorrow I am also going to try uh, to use GPU and train GPT-2 model on text generation. So to get my hands on fine tuning, I am able to understand the every bit of this concept. And also let's try out if my API is this I already created is able to extract the text from one of the PDFs which is shared with us today. So let's use this government sponsored program. And since we have already seen the custom JSON and JSON output of my API, so let's try the text this time and let's execute. So we will see how much text my API is going to extract from this PDF, and to make sure we can also open this PDF site. Okay, it's taking some time to load. I don't know why my system is so slow today. So we can see that we have government-sponsored subsidy scheme. This is the natural project on organic farming, the PDF which I uploaded. Objective is to promote organic farming in the country by making available the organic inputs such as biofertilizers and everything, Department of Agriculture. And here what I am doing, I am just extracting the JSON output and then introducing LLM. But by using the custom JSON, we are not getting the like expected output from the LLM. So what I will try to do, I will somehow figure out a way to like generate a short text, or then I will provide this expected text to our LLM. So the LLM can like train its or store this knowledge with LLM, and then it will be able to respond on the of our questions related to this PDF. So that's I am now planning to approach this problem, or we can also use MongoDB Atlas, which we discussed today. So let's see. Thank you so much. That's all for today.